Good morning and welcome back to the Daily News Update. I'm Oliver and we've got a packed show for you today on June 16th, 2026. 3 stories that are going to help you understand how people are actually building with AI right now.
I'm Jane, and I'm genuinely excited about these. We're talking about some really practical stuff today, not just the hype cycle, but the actual mechanics of what works and what doesn't. We're starting with tool design, why most AI tools fail when you actually try to use them with language models.
Right. The core problem is that LLMs are way more literal-minded than we tend to treat them. We'll dig into what makes a tool usable versus a tool that just creates debugging headaches. Then we're shifting gears entirely.
To Peter Yang, who's basically built a personal AI operating system. He's running a newsletter with 140,000 subscribers, solo, using custom skills in Cursor and Claude to automate everything from editing to social media posting. It's a masterclass in moving beyond ChatGPT projects to actually executing work across apps.
And to close it out, we're looking at economics and model choice. OpenRouter just dropped Fusion, this new multi-model system that's scoring within 1% of Claude Fable 5 on research tasks at roughly half the cost. We'll walk you through how it works, when it wins, and where it still falls short.
3 stories, 1 coherent picture, better tool design, smarter automation architecture, and the emerging economics of running lean AI operations in 2026. Let's dive in.
So let's dive into the first story, AI agent tool design. And the core thesis here is pretty straightforward. LLMs are fundamentally literal-minded. They cannot infer context the way humans do. They can't read between the lines. They need explicit instructions.
Okay, but what does that actually mean in practice? Like, we interact with language models all the time, and they seem pretty good at understanding what we mean, even when we're vague. So what's different when you're designing tools for them to use?
Great question. The difference is human users fill in gaps. If you give a human a tool with ambiguous instructions, they'll figure it out or ask for clarification. An LLM doesn't do that. It just makes a guess, and if that guess is wrong, the whole task breaks. So the article identifies several failure modes. Tools with multiple modes are 1. Imagine a single function that can either search a database or fetch a file, depending on what you ask it. A human knows to pick the right one. An LLM, it picks the wrong one half the time.
So you're saying single purpose is better. One tool does one thing well, not one tool that tries to do everything conditionally. That makes sense, actually. It's simpler to invoke, too. What about the parameter descriptions? That's where you'd think clarity would be obvious, but I'm guessing it's not.
Exactly. Vague parameter descriptions kill reliability. If you say a parameter is optional context, an LLM has no idea what that means. Does it want a sentence? A paragraph? Is it for filtering or enriching? You have to be explicit. And then there's output format. Freeform text is a nightmare. An LLM generates text, we get text back. But then what? Parsing it is fragile. Structured outputs, JSON, XML, those work because there's no ambiguity about what you're getting back.
And error messages, I'm guessing, matter too. Like, you can't just say error, invalid input, and expect the LLM to know how to fix it.
Right. Generic errors are useless to an LLM. You need specific, actionable messages. Tell it exactly what went wrong and what the acceptable values are. The bottom line is this. Designing for LLMs means being brutally explicit. Tool naming matters. Parameter descriptions need to be crystal clear. Minimal required parameters with sensible defaults. And examples in the documentation so the LLM actually understands how to use it. Basically, you're treating the LLM as a user who can't infer anything because it can't.
That's actually a useful constraint though, right? Because even if you're not using it with an LLM, those same principles make tools more reliable and easier to debug overall. You're forced to think through what's actually ambiguous
Absolutely. It's design discipline. And once you get it right, the tool becomes predictable, not just to the LLM, but to everyone using it.
So you're saying single purpose is better. One tool does one thing well, not one tool that tries to do everything conditionally. That makes sense, actually. It's simpler to invoke, too. What about the parameter descriptions? That's where you'd think clarity would be obvious, but I'm guessing it's not.
Exactly. Vague parameter descriptions kill reliability. If you say a parameter is optional context, an LLM has no idea what that means. Does it want a sentence? A paragraph? Is it for filtering or enriching? You have to be explicit. And then there's output format. Free-form text is a nightmare. An LLM generates text, we get text back, but then what? Parsing it is fragile. Structured outputs, JSON, XML, those work because there's no ambiguity about what you're getting back.
Okay, so JSON or XML removes the guessing game on both ends. The LLM knows exactly what structure to produce, and you know exactly what you're going to receive. That's huge for reliability. But what about when things go wrong? Error messages?
Right. Generic errors are useless to an LLM. If it gets a response that says error, invalid input, it has no way to know how to fix it. You need specific, actionable messages. Tell it exactly what went wrong and what the acceptable values are. Maybe it tried to search with a negative number for the limit, so you say limit must be between 1 and 100. Now the LLM knows how to correct itself on the next attempt.
That makes sense. And I'm guessing tool naming falls into this same category. You can't just call something process and expect the LLM to know whether to use it for analysis or storage or transformation.
Exactly right. Descriptive names matter a lot. If you have multiple tools, the LLM has to pick the right one. Fetch user profile is infinitely better than get data because it's clear what the tool does. And then on top of that, you want to minimize the number of required parameters. Make as many optional as you reasonably can and provide sensible defaults. If a tool has 7 required parameters, an LLM is going to mess up at least one. But if it has 2 required and 5 optional with good defaults, you're much more likely to get reliable execution.
And I'm going to guess that adding examples in the documentation helps too. Not just describing what the tool does, but showing a concrete example of how to invoke it and what the response looks like.
Absolutely. Examples are critical. An LLM sees a concrete example and suddenly it gets the pattern. You show it what a valid JSON response looks like, what parameters to include, and it can replicate that pattern. Without examples, you're asking it to infer from descriptions alone, which is exactly how it gets things wrong.
That's actually a useful constraint though, right? Because even if you're not using it with an LLM, those same principles make tools more reliable and easier to debug overall. You're forced to think through what's actually ambiguous.
Absolutely. It's design discipline. And once you get it right, the tool becomes predictable, not just to the LLM, but to everyone using it. You've eliminated the sources of confusion at the design stage instead of discovering them in production.
All right, so now we're shifting gears completely. We're moving from how to design tools for AI to how one person is actually using those tools at scale. And the story here is Peter Yang. He's a former product leader, worked at Reddit, Meta, Roblox, and now he's running a newsletter with 140,000 subscribers, solo, by himself, using AI automation. And his approach is nothing like just firing prompts at ChatGPT and copying the results.
Okay, so what's different? Because a lot of people are using ChatGPT or Claude for productivity tasks these days. What makes Peter's setup a fundamentally different approach?
The key difference is execution. Most people use ChatGPT for text generation. You ask it a question, it gives you an answer, you copy and paste it somewhere. Peter's moved to actually executing tasks across apps via APIs. He's using Cursor and Claude code, which means the AI isn't just generating text, it's actually running code, calling APIs, automating workflows. It's the difference between write me a newsletter section and go write the newsletter section, edit it, post it to Substack, and promote it on social media, all automatically.
That's a massive jump. But how does he even start? Like, does he sit down and manually code every single workflow? That seems like it would take forever.
Actually, no. This is the brilliant part. He does a brain dump once. So he'll voice dictate using something like Super Whisper for maybe 10 minutes about a workflow he wants to automate. Like, here's how I edit the newsletter. I read the draft, I check it for clarity, I make sure the tone matches my voice, I format it for Substack. He brain dumps the whole thing into a voice memo, feeds it to Claude, and Claude structures it into a reusable skill, basically a text file with clear instructions and examples.
So the AI is learning his workflow by listening to him describe it once, and then turning that into a tool it can reuse. And I'm guessing once you have that skill, you can just point Claude code at it and say run this skill without re-explaining it every time?
Exactly. And here's where it gets even better. Those skills are living documents. After each conversation, Peter's asking the AI to update the skill file based on what they learned together. So the system is self-improving. The first time he does the newsletter editing workflow, the skill might be basic, but after 5 times, after he's given feedback and the AI has learned his preferences, that skill becomes really precise. It's like training a personal assistant, but you only have to explain it once, and then it gets smarter as you go.
Okay, but I'm curious about something. You mentioned the personal advisor skill. This sounds like more than just a skill for one specific workflow. How does that actually connect to Peter's bigger strategic goals?
Right, so the personal advisor skill is the meta layer. Peter maintains a Google Doc with his core principles, his business goals, his energy drivers and drainers. Basically, what matters to him and how he wants to spend his time. The personal advisor skill is connected to that document. So when Claude is working on something, it's not just optimizing for speed or efficiency, it's optimizing for alignment with Peter's actual values and long-term vision. If a task would drain his energy or pull him away from his core goals, the AI can flag it.
So the system is self-aware about its own impact on Peter's priorities. That's clever. But here's what I'm wondering, is you said the skills update themselves after each conversation. So the system is learning Peter's preferences, his patterns, his voice. But at what point do you worry that the automation is happening so smoothly that Peter loses touch with what's actually being done? How does he maintain quality control and human oversight when so much is running automatically?
That's the critical question, honestly. And Peter's answer is pretty pragmatic. He doesn't try to oversee everything, that would defeat the purpose. Instead, he focuses on the final 20%. So the AI handles the 60% of the work that's pretty standard: newsletter editing, social media drafts, data collection. But Peter is spending real time on the last 20%, reading through the work, feeling the tone, checking that it actually resonates with his audience. And he's also doing strategic review on the personal advisor document itself. Is the AI reflecting his values correctly? Does he need to update his principles because things have shifted?
So the human oversight isn't in micromanaging the execution. It's in maintaining the strategic North Star. Peter's not reviewing every draft. He's reviewing the system's understanding of his own goals. That's actually smart because it scales. But you mentioned earlier that he's doing this across 140,000 subscriber newsletter, plus social media, plus apparently thinking about business strategy. How does he actually keep the skills updated and accurate when there's that much activity flowing through the system?
He's got a learnings.md file that the AI maintains. After each major conversation or project, Peter asks the AI to save the strategic insights. What did we learn? what should change about how we're thinking about the newsletter or the business. The AI writes those down, but here's the key. It asks permission first and keeps entries short, just 1 or 2 sentences, so Peter's not drowning in documentation, but there's a living record of what's changed. And then when the AI is about to update a skill based on feedback, it references those learnings, so the updates are actually informed by the bigger picture, not just one-off preferences.
So the system is designed to improve, but with checkpoints that keep Peter in the loop on what's actually changing. That's the balance, is high automation, but strategic human oversight. And I'm guessing the fact that Peter came from product at places like Reddit and Meta, where you're thinking about scaling systems, probably means he built this architecture intentionally. He didn't just stumble into this workflow. He designed a system that could scale to handle real volume without requiring him to be hands-on every single day.
Now, let's talk about what this actually looks like in practice. Peter's set up automated weekly briefings, revenue numbers, content performance metrics, competitor analysis. But here's the thing, most of those APIs he's using didn't exist when he started. He had to figure out how to pull data from places that don't have public APIs. The system now runs every Sunday morning and generates a briefing that sits in his inbox before he wakes up.
Wait, so he's pulling data from systems that don't have official APIs? How does that even work? That sounds like he's reverse engineering integrations.
Exactly that. For most things, yes, he uses browser automation where APIs don't exist. But here's the really interesting part. When he was trying to auto-post to Substack, he discovered Substack has internal APIs that aren't officially documented. He sniffed them out and figured out how to use them. So now his workflow is, he dictates a post idea, the AI generates platform-specific versions for X, LinkedIn, Substack Notes, and email, then one approval from Peter, and it posts to all of them automatically.
So he's solved the multiplexing problem. One idea becomes 5 different posts tailored to each platform, posted in one action. That's scaling the final product without scaling the work. But I'm curious, if that's the 90% that's automated, what's actually taking him days? That's the part that doesn't make sense to me yet.
That's the insight that matters most, honestly. Peter says the 80% of the work takes hours. The final 20% takes days. The 80% is the mechanical stuff, collecting data, drafting content, posting to platforms. The final 20% is the human part, reading through the newsletter, feeling whether the tone is right, checking that it actually resonates with his audience. Does this section flow? Does it connect to what he said last week? Is there a piece that just doesn't land? That's taste and judgment. The AI can't do that at scale.
So the automation buys him time to be editorial, essentially. Instead of spending 3 days on mechanical work and 1 day on actual judgment, he spends maybe an hour on mechanical work and 3 days refining the voice and impact. That flips the ratio entirely.
Exactly. And this is where it becomes relevant to Chris's portfolio approach, the one where he's launching multiple small bets. If Peter had to do all the mechanical work himself, he could maybe run one newsletter at high quality. But because 80% is automated, he's freed up to think about what else he could build. He's got the systems in place for one major project to mostly run itself, which means he can start thinking about the second one. The economics of solo operation change completely when the boring stuff is automated and the human time is allocated to the decisions that actually require taste and judgment.
Alright, so let's shift to the final story. OpenRouter just dropped something called Fusion, and it's getting a lot of attention because it's challenging the entire model economics game. The core idea is clever. Instead of asking one model to solve a problem, Fusion sends the same prompt to multiple models in parallel and then uses another model as a judge to synthesize all their answers into one response.
Wait, so you're running the prompt through multiple models at the same time? That sounds expensive. What's the actual workflow here? Does each model get the same tools and context, or are they working in isolation?
They all get the same context and the same tools. So if one instance of Fusion is running a research task, every model in the panel has access to web search, web fetch, bash execution, all the same capabilities. But they're thinking about the problem independently. One might go deep on source A, another might focus on source B. One might catch a blind spot that another misses. Then the judge model reads all the outputs, looks for consensus, contradictions, unique insights, and synthesizes them into one final answer.
So, you're crowdsourcing thinking, basically. Multiple angles on the same problem, then finding the best synthesis. And I'm guessing you can customize which models are in the panel. Like, you're not locked into using the same set of models every time.
Exactly. You can build custom panels. The article shows a few examples. The budget panel uses Gemini Flash, Kimiko 2.6, and DeepSeek V4 Pro, cheaper models but run in parallel. There's a premium panel that pairs Fable 5 with GPT 5.5 and Opus 4.8. Or you could just run the same model twice through the synthesis loop, Opus plus Opus, and it still improves the score. That part is really interesting because it shows the value isn't just in model diversity, it's in the synthesis itself.
Hold on, running Opus twice, just the same model thinking about it twice with a judge, improves the score? That seems almost too simple. But I guess that makes sense if the judge model is actually good at spotting what each instance missed.
What kind of score improvement are we talking about?
The article tested this on the Draco benchmark that's 100 research tasks across 10 domains with 39 weighted criteria for evaluation. When you run Opus through the judge model twice, the score improves by 6.7 points. That's substantial. And when you use a diverse panel, the budget panel of 3 cheaper models, it scores 64.7%, which is almost exactly matching Claude Fable 5's 65.3% performance, within 1% at roughly half the cost.
So the benchmark they used is called Draco. It's 100 research tasks spread across 10 different domains. And here's where it gets interesting. They're not just measuring speed or accuracy. They're using 39 different weighted criteria, things like accuracy, breadth of research, how well you synthesize information, citation quality. It's a pretty rigorous test of whether an AI can actually do deep research work, not just generate plausible-sounding text.
Okay, so this isn't some toy benchmark. They're testing real research capability. And the results on that benchmark, what are we actually seeing? Because you mentioned the budget panel was competitive with Fable 5?
Yes, so Claude Fable 5 scores 65.3% on Draco. The Budget Fusion panel, that's Gemini Flash, Kimiko 2.6, and DeepSeek V4 Pro, running in parallel through a judge model, scores 64.7%. That's within 1% at roughly half the cost. And then the Premium panel, which pairs Fable 5 with GPT 5.5 and Opus 4.8, actually beats Fable 5 alone at 69%.
So you're saying the budget panel is nearly as good as Fable 5, but cheaper, and the premium panel is actually better. But what's the actual cost difference? Like in real dollars, what are we talking about here for someone running this at scale?
Right, so here's the breakdown. Fusion is roughly $1.5 to $3 for input and $4 to $6 for output per million tokens. Fable 5 is $3 to $6 for input and $9 to $15 for output per million tokens. So you're looking at Fable being roughly twice as expensive on the output side, which is where the cost really adds up for research tasks that generate a lot of text.
Twice as expensive on output is a big deal. But what does that actually mean if you're running, say, a research operation that's consuming 10 million output tokens per day? What's the monthly savings?
At 10 million output tokens per day, you're looking at roughly 300 million tokens per month, With Fable at $9 to $15 per million, that's $27 to $45 million per month. Let's call it the mid-range, around $35 to $40,000 per month. With Fusion at $4 to $6 per million, you're at $1.2 to $1.8 million, let's say $1.5 million. So you're cutting the monthly cost from roughly $90,000 to $150,000 down to $40,000 to $60,000, depending on which panel you use.
That's massive. We're talking about cutting operational costs nearly in half while maintaining quality or actually improving it with the premium panel. But here's what I'm wondering, that savings assumes you can actually swap out Fable for Fusion everywhere. Are there cases where Fable is still the better choice, or can you really just make that switch and pocket the savings?
That's the critical question. Fusion excels at parallel research tasks, exactly what Draco is testing. Multiple models thinking independently, then synthesizing. But Fusion struggles with long-horizon sequential work where you need persistent state across many steps. If you're building something that requires a single model, maintaining context, and making decisions based on an accumulated history, Fable 5 is still the better choice. So it's not a simple replacement everywhere. It's more about understanding your use case. Use Fusion for research, analysis, and varied tasks. Use Fable or another single model approach for sequential workflows where consistency and context memory matter.
So here's what I'm wondering, that savings assumes you can actually swap out Fable for Fusion everywhere. Are there cases where Fable is still the better choice, or can you really just make that switch and pocket the savings?
That's the critical question, honestly. Fusion is phenomenal at what it does. Parallel research tasks where you benefit from multiple perspectives synthesized together. That's exactly what Draco is testing. But Fusion struggles with long-horizon sequential work, where you need persistent state across many steps. If you're building something that requires a single model, maintaining context, and making decisions based on an accumulated history, Fable 5 is still the better choice.
Okay, so when you say persistent state and long horizon sequential work, can you give me a concrete example of what that actually means in practice? Like, what breaks when you try to use Fusion for that kind of task?
Sure. Imagine you're building an AI agent that needs to work through a complex problem over multiple steps. Step 1, it analyzes the data. Step 2, it identifies patterns. Step 3, it draws conclusions based on those patterns. Step 4, it refines those conclusions based on what it learned in Step 3. Fusion is running multiple models in parallel each time, so each one is independently analyzing and reaching different conclusions. The judge model synthesizes them, but you've lost the continuity, the accumulated reasoning that builds on itself. With Fable, you get that linear history of thought. The model can say, I concluded X, so now I'm going to test it against Y. That accumulated context matters.
So it's about coherence over time. With Fusion, you're getting diversity of thought, but you lose the thread. That makes sense. Are there other cases where single model approaches win, like compliance or security issues, where you need to trace exactly what a model decided and why?
Absolutely. If you're in a regulated industry or doing something where auditability matters, like financial analysis or medical recommendations, you often need to be able to explain exactly how the AI reached a conclusion. With Fusion, you've got multiple models thinking differently, a judge synthesizing them. That's harder to audit and trace. You can argue it's more robust because you've got multiple perspectives, but from a compliance perspective, a single model with clear reasoning is often easier to justify.
So the architectural decision comes down to your use case. You're not choosing based on which model is better. You're choosing based on whether you need breadth or depth, parallelism or continuity.
Exactly. Use Fusion for research, analysis, fact-checking, anything where multiple angles add real value and you don't need to carry context forward. use Fable or another single model approach for sequential workflows, long horizon planning, and anything compliance sensitive. And honestly, in a lot of real operations, you're probably using both. Fusion for the research layer, Fable for the decision-making and execution layer. They're not competitors, they're different tools for different architectural needs. Alright, so here's what strikes me about these three stories. They're not separate trends. They're actually layers of the same thing. Better tool design gives you the foundation for reliable automation. Peter Yang's entire system only works because the tools he's built are agent-friendly. If his skills and integrations were vague or ambiguous, the whole thing would fall apart.
Right. He's not fighting the AI to make it work. He's designing tools that the AI can actually execute reliably. And then that reliability scales. Because once the tooling is solid, you can build architecture on top of it. Personal operating systems, automated workflows, the whole stack.
And then the third piece is economics. Peter's running a 140,000 subscriber newsletter solo because he solved the tool design problem, which let him build an architecture that's 80% automated. But that whole equation only makes sense if the economics of running that system don't bankrupt him, which is where Fusion comes in. The cost efficiency, cutting operational costs nearly in half while maintaining quality, that's what lets a solo builder like Peter, or Chris with his portfolio approach, actually maintain margins while operating lean.
So you're saying it's a whole stack. Layer 1, you design tools that are explicit, unambiguous, structured. Layer 2, you build a personal OS around those tools, reusable skills, strategic documents, self-improving loops. Layer 3, you choose your models and systems based on actual use cases and economics, not just raw capability. You don't overspend on Fable when Fusion is sufficient. You allocate expensive models to the sequential work that actually needs them.
Exactly. And the coherence here is that none of it works in isolation. If Peter had great tool design but didn't have the architecture to automate, he'd still be drowning in work. If he had the architecture but was paying 3 times as much for models as he needed to, the economics wouldn't work. It's all interconnected. And for anyone building AI-assisted businesses in 2026, that's the strategy. Think about all 3 layers: good tool design, smart architecture, and ruthless economics. That's how you actually scale as a solo operator or small team.
And the beautiful part is that this is all happening now. The tools exist, the frameworks exist, Peter's methodology is reproducible, Fusion is available today. So if you're someone thinking about launching multiple small bets like Chris, or running a newsletter or a small business solo, you don't have to invent this from scratch. You can use these patterns right now. Design your tools well, build reusable systems, make smart choices about which models do which work. That's your playbook for 2026.